All right, so let's go ahead and get started with today. Okay. So what we're going to do today is identify parent functions and describe characteristics of their graph. Perform transformations of functions. We probably won't get into that today. So again, today we're just going to go ahead and try to familiarize people, get you familiarized with the parent functions. So what is a parent function? So a parent function is like the most basic graph, all right? The most basic way that you can have something happen basically with all the elements. Now, every function must have an input and an output. So in this case here, this X is our input, right? Remember we were talking about that when we were starting chapter 2. You have an input here and your output there. So if you plug in a number here, you're going to get something on the other side, on the y-axis. Now, okay, so you have a line. So in this case here, we just have a slope of 1, and it passes right through the middle, the origin, right? Because that's the 0, 0. So there's no y-intercept. Well, the y-intercept is just 0, and again, the slope is 1. And that's the most basic way we can have all of the elements that we need for this linear function. So again, linear just means line. And all you're doing is just filling this part out, okay? Just because you'd have to do this anyway for one of the lessons that are coming up. I'm not sure if we'll be able to get to it this week just because, well, we don't have school on Friday. So that's a reminder to you that there's no school Friday. So the domain is all real numbers and the range is all real numbers. So just fill this out as we go along. X-intercept is 0, y-intercept is 0, 0 as well. So they both, again, cross right through the origin. Maximum number of roots. So what exactly is a root? Well, a root or a 0 is where it crosses the x-axis. So this line can only cross the x-axis one time because it has to go somewhere pretty much. And then we also have end behavior. So as x goes to infinity, and what this means is as you go to the right, the y value will also go up. So as x goes to infinity, the line is going up, and that's how you would read that. So it goes up towards infinity. As x goes to negative infinity, so as you go backwards, so backwards. So as we go to the left, the line is going down, and it's going to reach the y-axis here in the negative. And the last trait is that it is continuous. Continuous means that there are no holes or gaps or breaks in the line. So I'm going to just show you on Desmos. Let me go ahead and just switch over to Desmos, and I'm going to just type in y equals x, and that should be our most basic line function, like that. And again, these lines go on forever, right? They don't just stop a little ways. And I've been telling you that every time you graph it, you got to graph it all the way. So I mean, I can zoom out, and I could be here all day, and we're always going to be able to go somewhere. So every ordered pair has a x and y value, right? They have an x and a y value. So see how the x is going up? So here it's going to be about 1. And as I move to the right, it's also going up. So as x goes up and up, y is going up and up. So that's why we call it the end behavior, because it's as you have to go one way, and in this case I'm going to go back the other way. And as I go down, as x decreases, y decreases, and again it goes on to infinity. And there are no holes or gaps. Sometimes you can do lines that do have holes and gaps, but that's for another time. All right, then you have the absolute value functions. We're probably going to work on some more of these later, probably next week. but it kind of looks like the line function, except remember, one of the traits about absolute values is that you cannot have a negative value, right? If you put in a negative number for x, it just becomes positive. So as we try to go back this way, the negatives are erased and then the line is kind of turned back up. And that changes the end behavior as well. So the end behavior, as we go towards positive infinity, the number for y goes towards infinity also. And as x goes backwards, so as we're going backwards to negative infinity, our line is actually going up. So the y values are going up. So that's why the end behavior is different than the other one. Maximum number of roots. So again, that's how many times you can cross the x-axis. And let me go ahead and maybe switch over to the Desmos again. So in this case here, I don't know, absolute value is this one here. And there you go. Now we have our absolute value function and it looks just like a line, but again, it curves back up here. Now, parent function, again, is the most basic form of the function. You can change a couple of things, like if I want to move it to the side, so I meant to put the cursor here. But if I want to move it to the side or move it up, I can do that. We can move this around. If I want to move it down 6 instead of up 6, I can go ahead and just do that. So now you can see that it's crossing the x-axis in 2 different places. So it can have more than one crossing of the x-axis. There's also, if I imagine the range and domain, right? So the domain, if I were to have something like that, like go ahead and move back down here. So if I were to cross the vertical line, we have all real numbers. If I move any vertical line straight from one side to the other, that is all real numbers. But there's a problem with the range, and that is if I try to do the range, so I have another line here to run the range. As I go down here, oopsie. Okay, here I have areas in my y value, right? The lowest value for y I can pick is going to be -6, but I have nothing below that. We don't touch the function below this area. So that's why the range is also different. So if you look at our range for the parent function, we can have anything at 0 or greater than 0. So each of these graphs again have little traits that are a little bit different than the others. And again, the main important thing you do with this one is you just copy it down. That's like pretty much all we're doing today. That's all we have time for. Because it's early dismissal, but I feel kind of weird adjusting my schedule. Maybe I'll ask you guys after this, if you feel like you would rather just have classes earlier in the day on half days. You know, I'd have to adjust the schedule and I'd have to send out reminders like the day before and maybe probably the morning of as well. But think about that. Would you rather have, you know, like regular timed classes, or would you rather have classes that start a bit earlier, like let's say 11 o'clock or 10 o'clock or something? I don't know what the schedule says, but it would be around that time period. Anyway, moving on. Quadratic. So this is actually what we're going to start in the next unit. So after next week, this is what we're going to be working a lot with, probably for most of the course. So you get y, and oh yeah, and don't forget f of x just means the same thing as y, so y equals x squared. So x is being squared. Now all of these linear and absolute value functions and quadratic, cubic, and all the other ones we're going to cover today, they all describe what is happening to the x. In this case, x is being squared. So since x is being squared, any number I put in there, so if I put in 0, 0 squared is 0. If I put 1 in here, 1 squared is 1, right? And if I put 2 in here, so x is 2, so go to the x-axis at 2 and square that, you get 4. So it'll cross right there, and so on. The domain for this one is all real numbers. Now, even though the arms of the parabola, that's what the shape is called, parabola, even though it shoots up pretty steep, all right, and it does get steeper the higher up you go. It still covers all real numbers, all right? So eventually you will run into a number that you're looking for. It doesn't, sometimes even though it doesn't look like it, it will reach those numbers. So it goes up and covers it in both directions. And just like the absolute value, the y is going to be, the range for y values are going to be anything equal to or greater than 0. So we can't pick anything for the parent function. Like if I pick -1, our line would not touch the function. X-intercept is 0, 0. And again, these things change. You can always add things. I think in most Algebra 1 classes, they at least talk a little bit about quadratic functions and parabolas. And you'll notice that this is, again, sometimes you'll have numbers added, sometimes you'll have numbers in front of the x, sometimes you'll have a b value is what we call it. But anyway, yeah, those are all things that we have going on. But this is the parent function. It's just, again, the most basic function that you can get. And let's see, maximum number of roots or zeros is 2. Now, if you can imagine, take that parabola and lower it a bit, it can cross your line twice. And again, it goes up in both directions. So as you go to make your number larger, it's going to make the y larger, so it's going up. And the same is true if you're going back the other way. If you're going backwards, as you go towards -infinity for x, it still goes up. And it's also continuous because there are no holes or gaps in that. There are no holes or gaps in that shape or breaks. So if I wanted to make if I want to use it on Desmos, and this is a good thing to know, how you get the power on Desmos, you can just push this button down here, but we're gonna need some other powers. I'm gonna push the home button. So now we can see our parabola. And again, it kind of shoots up really fast. It gets steeper and steeper as you go higher and higher. But our domain is all real numbers. So if you can imagine passing a vertical line through it, it doesn't touch it more than once. But for the range, we have nothing, 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 nothing. And as soon as we get to 0, now we reach the line. So now we have numbers in the range. And if I lower it, which I can lower this graph, if I lower it a bit, I do end up with some of these zeros. Right? You can also do other things with this, and again, we're not really worried about this, but you can also change the opening, so you can have it open this way. You can also make it wider or make it narrower. And these are all things that we're going to learn later on, but right now, again, we're just getting ourselves familiar with the parent function, and that's all we're doing today. And now we have the cubic function, which is the same thing as quadratic, except we're raising it to the 3 power. And again, all these are happening to the x. You're describing basically what's happening to the x. You have 3 power. So domain is all real numbers. Again, it shoots up pretty fast, pretty steep, but you can go to domain of 100, but you are going to get a really, really big number, probably in the millions, depending on what your values for the function are, but you will get a number. So even if it's way up there, it still counts. But this one's a little bit different because the range is all real numbers. If I imagine a line, right, this line has directions in both directions. So it's going to go down forever, and it's going to go side to side forever. X-intercept is 0, 0. Y-intercept is 0, 0. Now this one's an interesting one because you can have 3 roots. You can have 3 crossings of the x-axis. Now this one's a pretty neat one to go with, but let me just go ahead and go over the end behavior really quick, and I'll come back to this. Our end behavior, as we go towards infinity, so x goes this way, that line kind of goes up. And as we go backwards, that line goes down. So it goes to positive infinity. As you go to negative infinity, it goes to negative infinity. Y goes to negative infinity. And again, it's continuous. There are no holes or gaps or breaks. That's probably also going to be another lesson, because sometimes these functions, they do break, meaning that you might have two separate kinds of functions. The line is not just from one side to the other. So anyway, let's look at some of these cubic functions. I don't really have any good ones to go with, but let me just try one. And I don't really know how to write a good one that works, but this is the only way I know how to make them write good ones that work the way I want them to. There we go, got one. Now these, if you look at the parent function, let me go ahead and make a new function for the parent function, and that one's just going to be y equals x to the third. But this one here is I have to show you how to write the third power. So you're going to push Shift if you're looking at a keyboard. Shift 6. You're going to see a little tiny sign that looks like an upside down V. It's called caret. Yeah, it just looks like an upside down V. That's the best way I can describe it. But that allows you to make your number into an exponent now. So you can see my black line here is the parent function. And again, it's very basic. And you can see that my blue line actually looks kind of like an N. And it crosses the x-axis 3 times. And you're also going to notice I put 2, 2, and 4 as my numbers. And here I end up with 2, 2, and 4 as well. So that's kind of cool, isn't it? You have this bendy figure here. But anyway, that's a cubic function, and that's why you can have a maximum number of roots of 3, because yeah, you can make this look like an N, or and you can also do other things with these too. You know, it's really fun sometimes to just go in and play with the graphs from this here. So like, what would happen if I were to make this negative? You see it flips. Kind of looks like a jump rope if you do it really quick. But yeah, you can see how affecting any of those numbers can cause a change in what's going on. Same thing with this one here too. I can make this one flip to negative and it just reverses it. Okay, so let's go ahead into the next one. And this one's going to be the square root function, which you are taking the square root of x. With the square root function, remember we were doing square root numbers like probably the second week of school. We were kind of reviewing square root numbers. So some of the things about square roots, one of the characteristics about looking at the equations is that you cannot have a negative value inside the radical. Remember, that was one of the things that I kept saying. Since you cannot have negatives in the radical, if you try going y down, it stops. You cannot have the line continue on like that because you cannot have negative numbers in the radical. So that's why there is no bottom half of this. It's actually a parabola turned sideways. So if you take the parabola and you turn it sideways, that's essentially what's happening to it. But it's only one side of it. So anyway, the characteristics, the domain are values greater than or equal to 0. So if I put a vertical line here, okay, that's not a very good vertical line. But if I did a vertical line here, you could see that there would be no domain. I'm not able to reach the function. And the same as if I were to draw a y horizontal line here, there'd be nothing until I get to 0. That's the lowest number that this goes to. So this one's kind of a different one because now it's starting to look a little bit more weird. However, it does intercept the line. Even though it doesn't cross, it still like touches it. Since it touches, it's considered an intercept. So it doesn't necessarily have to cross it. And with this shape, if you can imagine just bringing it down a little bit, you can get a 0. So like, again, you can mess with some of the numbers in the formula and get this line to do things. You know, you can get it to move up, move it down, side to side. You can kind of what you call stretch or compress them. But again, that's probably going to be another lesson for another day. But today we're just sort of filling out this reference chart. As x goes to infinity, so as we move to the right on this graph, the y values go higher and higher. And again, they will go to infinity at some point. And x here to the negative infinity. So as x goes backwards, so going to the other way, if I go this way, the lowest value I can get to is 0. Once I reach 0, that's it. We can't go past that. And this line is discontinuous. It does not continue from one side to the other. There is a break in it. So since there is a break in it, it is not continuous. All right, so hopefully you know what continuous means, right? It means like one string of things. Like if somebody said, I ate 20 hot dogs, you'd be like, that's not impressive. But if they said I ate 20 hot dogs continuously, then you'd be like, okay, that's impressive. Because, you know, it is hard to eat 20 hot dogs. Anyways, let's go ahead and go to the cube root function. Now, this is kind of the same thing as the other one. You can make this, if you remember the other one, you can make it look like a, the cube function, the cubic one. You can make it look like an N. If you were to stretch this one out, you can kind of make it look like an S. If you were to stretch it out a little bit, put some numbers in there. Oh, shoot, sorry. I don't mean to answer my phone. I'll just throw it over here instead of silencing it. All right, x-intercept is 0, 0, y-intercept is 0, 0. And again, it goes in both directions forever. And even though it's S-shaped, even if you get it really, really S-shaped, if you move it up and down, you know, you're not going to cross your x-axis more than once. And end behavior, so as we go to the right of the graph, right, as we go down this line, the x, as x increases, the y is also going to increase. And it can do so infinitely as well. Same thing if I go to the left, so I'm going back the other way. If I go x into the negative direction, my line goes down, 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 down. And again, also forever. This one is also continuous in that there are no holes or breaks or gaps in this line. And it's kind of hard to, I mean, I know I've been talking about that most of the morning as well. But sometimes people, I get them asking, what about the holes in the break? What do you mean by that? Maybe somebody has that question but hasn't really answered it. Maybe if we have some time today, I'll see if I can fit an example in there with some holes or breaks. But anyway, yeah, like in this case, that one's broke. There's a break here. It just sort of stops and doesn't go any further from there. All right, so hopefully you copied all this down. Let's move on to the next one. Reciprocal function. Now with the reciprocal function, if you're copying it, you got to pass through -1, -1, and up 1 over 1. So your line kind of comes, well, if we're starting from left to right, your line kind of goes in and then it kind of dips really sharp like that. So it just dips down? Okay. It's just some stuff about the staff meeting later today. I'm going to turn that off because I'm pretty sure they're going to keep texting and saying what are we going to talk about during the meeting and everything else like that. Not really that important right now. But anyway, there you go. So these are what you call asymptotes, meaning that if you follow the line, it goes closer and closer to this line, but it does not touch. Now, since it never touches the x-axis, there is a break in the domain. So you can have any x as long as x is not 0. That's the way you would read that. Any x such that x is not 0. So you can pretty much pick anything except for 0, and any y for the range as long as y is not 0. So again, pick anything except 0. Does it have an x-intercept? No, so we put this not applicable because it does not cross the x-axis. And in fact, again, it gets closer and closer, but it never actually reaches it. Same with the y-intercept, goes closer and closer, but never really intersects, never touches or anything like that. Maximum number of roots is only 1. We can only cross the x-axis once. Now we can mess with this a little bit because again, in this case, we're looking at the parent function, but you can move these up and down or side to side. And if you move it up or down, one of those lines is going to cross the x-axis. And this one also has different end behavior. So end behavior is like, again, if you're going towards the negatives or towards the positives, what is the line doing? What is the function doing? And in this case, as we go from x, so as we go to the right, the line gets closer and closer to 0, but again, it doesn't actually touch 0. I'll show you an example of this one on the Desmos. And as we go back the other way, as we go to the left, we go closer and closer to 0, but we don't actually reach it. And now this one is discontinuous because there is a gap from here. It goes down, and then it all of a sudden appears from the top again. So that's kind of a weird like teleport thing going on right there. And this one has asymptotes, and that's the way you say it. X equals 0, y equals 0. So there is a line there that it goes towards but never actually touches. So let's look at some of these things on Desmos. So the reciprocal function is just 1 divided by x. There we go. So we got our function down. And again, I'm going to move my domain, my domain marker. Look at the intersection right here. You can see a little gray dot. As I move it more and more, come back, you little dot. There you go. As it goes down, as I go to the right, it goes down, down slightly. Then all of a sudden, goes down really fast. And from here, there's our asymptote of 0. At this point, my green line is not touching either of those blue lines, but it'll kind of reappear the intersection. Hopefully that gray dot comes back. There you go. See, it's back. So that little dot comes from the top and it moves down the line on this way. And you're probably thinking to yourself, okay, it looks like it's getting pretty close. I'm sure it will cross that line. And if I go to, let's say 100, you might be thinking, okay, well, it's touching the line. All right, but just like that TV show, the CSI, zoom and enhance. Nope, not touching. All right, and I could go to 1,000 or something. Let's go to, well, maybe not 1,000. Let's go to 300. See if that does any better. So if I zoom into 300, really, really, really close, but it's not actually touching that number. So that's 3 thousandths, right? So that's a really small amount. So if you had 1,000, like if this was an inch and you cut it into 1,000 pieces and you would take 3 of those, that's about what this would be. That's a really, really small number. And again, it goes closer and closer, but it never actually reaches that line. And the same thing happens with the range as well. So as I increase the range, my dot goes back the other way and it teleports from the right and then continues back up. See? Okay, I don't know if I was screen sharing that.
Yeah, we didn't see it.
Didn't see it? You guys should have told me something sooner. Oh well. Because I can't see when I'm screen sharing. I mean, I wish it would just show us everything, just show everything on my screen. You know, I don't know why I have to select screen share. But anyway, yeah, there you go. So I just showed you a couple of things with the graph. Let's go ahead and go to logarithmic. And this one's a little bit of a different thing. Yeah, it's very, oh, wait a minute. Oh, I don't know if we didn't cover exponential. So let's just do that really quick. So domain is all real numbers. So again, this line is continuous. Even though it shoots up really fast right here, we can go all the way this way. And y values, so y values, we can choose anything as long as it's greater than 0. Now this one does not have the or equal to, because there is an asymptote on the y-axis. The asymptote is the line that it won't cross, so it will not cross 0. So as I go this way, it's going to get closer and closer, but it's not actually going to touch it. So since it's not going to intercept, then it's I can only pick y values greater than 0. Or yeah. Now this one has a different x-intercept. It crosses at 1, 0, which is right there. Or is it, I think I got this one backwards actually. I think it is backwards. I'm pretty sure it's supposed to be not touches the x-axis, but does touch the y-axis. All right, I gotta fix that one later on down the road. Probably after this. Maximum number of roots. So again, I can move that graph down a little bit and it will cross the x-axis one time. But I'd have to mess with the parent function. Oh yeah, and this one's also 2. Exponential, I think the smallest number you can pick is, well, I think 2 is again the normal one, because if you put a 1 in there, 1 to the 1 power is 1, 1 to the 2 power is 1, 1 to any power is always going to be 1. Your end behavior, as you go to the right, it goes up. As you go to the left, it goes closer to 0, but never actually touches. Now, this one is continuous because it's just one line from one side to the other. So that one counts as continuous. All right, logarithmic. So this is the last one. Now, logarithms are a little bit different. In fact, I don't know if we're ever going to be able to finish this one here. So in Algebra 2, there are 6 units, and this one's one of the last ones. And seeing how this year's going, seeing how the progress is very slow, I'm probably going to have to cut that one out to make it so that we at least cover the most important things in Algebra 2. So with all the other graphs, we might come back to them, but this one I don't think so. We're already halfway. We should be finishing up polynomials by now, which is unit 3. But seeing as how it's already the end of the first quarter, I don't think we're going to get through it, you know. So it may not seem like it, but actually this year, if you keep up with your work, this is actually going to be kind of easier than a regular Algebra 2 class, because we're only covering about, right now we're about 2/3 of the way when we should be half of the way. I'm sorry, we're 2/3 of the way of halfway. Okay, we're not where we should be. Anyway, domain is anything greater than 0. I thought I turned it off. Domain is anything greater than 0. I cannot have anything under here. And the range is all real numbers. Even though it kind of shoots off very sharply this way, and it's kind of shallow, it's still going up, even just by a little bit. And it still goes up and up forever. Now the x-intercept is 1, 0. So it's crossing right here. Now logarithmic is kind of the opposite of exponential, what we call inverses. So like we know inverse operations, you know, add and subtract are inverse. multiply and divide are inverse. Logarithmic is the inverse of exponential. So let's see, this next one here, y-intercept doesn't actually touch, and this one has an y-intercept at x equals 0, so again, it doesn't actually touch the x-axis. And our end behavior as we go to the right, so as x goes to infinity, the y goes up to infinity also. And we can't go to negative infinity. The line, if we go backwards on the x-axis, it just goes down. So as we try to get closer and closer to 0, the line just keeps going down lower and lower to negative infinity. But this line is continuous though. Now, I said I was going to kind of mess around with some things. Let me go back and show you some of the things that we missed. Sometimes I think I'm screen sharing, but it doesn't. So I was pretty sure I clicked on this. But anyway, this is back to that reciprocal function. And I'm just letting people, I was just showing you that as I move this line, so you can see that there's an intersection here, a little gray dot. And as I move it up, look at the blue line and it just sort of teleports right there. And it kind of appears to the other side and it goes up again. Same thing happens with this one here. If I look at the intersection here, goes down, down, and then it appears up there and it starts going down again. And again, I can move these graphs a little bit. So if I plus 3, it's going to move it up. And now I have an x-intercept. But now when I change it, it's no longer going to be the parent function. It's not a parent function anymore. And for what do you call it? Exponential things. The exponential graph. Let me see. 2 to the x power. I said 2 to the x power. There we go. Okay, so kind of to I guess while we're talking about well, I don't know how people would feel about this, but the exponential graph is kind of like the way a disease would spread. So like if we have one person, right, and that one person goes out and infects 2 people, now two people will have the sickness. And if 2 people have it and they get each one other person sick, then that means each of those people by the next time it spreads, if 4 people get it, then 16 are going to have it. And so on. So it goes up really, really fast. And that's why it's important to listen to the news and stop it when it happens like that. So like you can get cases jumping really, really fast if you're not doing anything about it. But anyway, yeah, these graphs are, and yeah, that one it goes up really, really sharp. And it doesn't look like it's going sideways all that much, but it is going pretty sideways also. It just goes up really fast. Anyway, I think that's it for today. That's all I pretty much wanted to cover for today. So let me go ahead and go over the announcements. Anyway, that's it for today. If there is nothing else, I will see you tomorrow. Oh, Friday is no school, so don't forget that. And as always, I'll be around if you have any more questions. If not, then I'm going to go ahead and log off then.